Okay, this is section 5.2 on verifying trig identities. So here are some steps to or strategies for verifying trig identities. And these are things that we talked about in section 1. The first thing, what's going to look different in this section is that it's an equation. So we're going to have equals and something on the right hand side. And usually you want to work on the more complicated side of the equation. In our case, most of the time that's going to be the left-hand side. And you're not going to touch the right-hand side. That's what you're trying to get the equation to look like or transform into. So you're going to use the identities that we've learned to transform the expression. You're going to use any type of algebraic operations that we've learned in the past to try to simplify it and get the left to equal the right. So it's like I'm giving you the answer to the problem, you're just showing me the work to get there. So example 1, we have sine t times cosecant t equals 1. So what I'm going to do is I want to change cosecant t to something that I know that it's equal to. I'm going to leave the sine t, and I know that cosecant t is equal to 1 over sine t. Everything else in the equation is going to stay the same. I'm going to keep the equals 1 because I know that's what my answer is supposed to be in the end. And I'm going to show every little step, even though it seems common sense or you think that I would know what you're doing. I want you to show every step. So in this case, sine t times 1 over sine t is going to be sine t over sine t. And we know that anything divided by itself equals 1. So you're just showing me the steps to get the left-hand side of the equation to equal the right-hand side. Okay, number 2. This says cosine squared beta minus sine squared beta equals 1 minus 2 sine squared beta. So in this case, I'm looking at the right-hand side and I notice that there aren't any cosines over there. So that means somehow I need to get rid of this cosine squared beta if possible. So I know I've seen cosine squared before when I've used the Pythagorean identity. So remember, if you rearrange this identity, it can help you out in any of these types of problems. So if I rearrange this and solve for cosine squared, I know that cosine squared equals 1 minus sine squared. And I can use that in this problem. In place of cosine squared beta, I'm going to put 1 minus sine squared beta. And then everything else is going to stay the same. Well, then I notice I've got like terms here. I have a negative sine squared beta and another negative sine squared beta. So together, that's going to be negative 2 sine squared beta. And that's exactly what I was trying to get it to be, 1 minus 2 sine squared beta. Okay, number 3, I have cosecant squared theta divided by cotangent, and I'm trying to get that to equal cosecant theta times secant theta. So I see that I have one cosecant in my answer, so I know I'm going to need to keep one of those cosecants on the top, but somehow get rid of the other one and get rid of the cotangent and transform into secant. So what I'm going to do is I'm going to split the top apart, and that's going to be cosecant times cosecant. And then I know that a cotangent in the denominator is the same as tangent in the numerator. So 1 over cotangent is the same as tangent. Okay, and then everything on the right-hand side is going to stay the same. So I know I need to keep one of the cosecants, so I'm going to keep that first one and see what I can do to these other trig functions. So the second one, I'm going to change that to 1 over sine theta using the reciprocal functions. And then tangent, I'm going to change to sine over cosine using the quotient identities. The right-hand side is going to stay the same. Okay, then I notice that the sine thetas are actually going to cancel out here. And I would be left with cosecant times 1 over cosine. And I know that 1 over cosine is equal to secant. So you're just showing all of the steps that it would take to get the left transformed into the right. Okay, number 4. I have cosecant x minus sine x is equal to cosine x cotangent x. So somehow I need to get these two terms that are being subtracted transformed into one term that's being multiplied. So I'm going to start with taking the cosecant x and I'm going to change it to 1 over sine x. And then still minus sine x equals the right-hand side. So I know in order to add or subtract fractions, they have to have a common denominator. And currently, the second fraction is over 1. The first fraction, the denominator is sine. So that means the common denominator is going to be sine x. So I need to multiply sine x by the top and bottom of that fraction to get the common denominator. So the first fraction is going to stay the same, 1 over sine x, minus sine times sine will be sine squared, and then over sine x. Now that they have a common denominator, I can merge these two fractions together, and on the top it will be 1 minus sine squared x over sine x. I know I've seen this before. 1 minus sine squared is part of the Pythagorean identity that I can rearrange, and I know 1 minus sine squared is equal to cosine squared over sine. I'm going to go to another slide, and I'm going to keep this step the same. I'm going to split my cosines apart because I see in my answer that I have one cosine. Somehow I'm going to have to get rid of the second one. So I've got cosine times cosine over sine equals cosine x cotangent x. And I notice that cosine x divided by sine x is actually cotangent. Okay, this is the last example, and remember you can use any symbol or letter or shape that you want to that represents an angle. In this case I did squares and triangles, so square is one angle, a triangle is a different angle. I have tangent square plus cotangent triangle divided by tangent square cotangent triangle, and I'm trying to get that to equal tangent triangle plus cotangent square. So in this case, I'm not going to transform into sines and cosines because I know I need tangent and cotangent in my answer. So somehow there's got to be a way to simplify this without changing it to sines and cosines. So this time I'm going to split the fraction apart into two fractions. So the first fraction would be tangent square over tangent square cotangent, plus the second fraction will be cotangent triangle over tangent square cotangent triangle. And then I keep the right-hand side the same. Okay, then I notice on the top and bottom of the fraction there's some things that will cancel. Tangent squares will cancel for the first fraction, and cotangent triangles will cancel on the second fraction. Now on the top of these fractions I'm still left with a 1, so this is going to be 1 over cotangent triangle plus 1 over tangent square. And then I can use the reciprocal identities here because 1 over cotangent is equal to tangent triangle. And then 1 over tangent squared would be equal to cotangent square. Okay, so you're using those identities as much as you can to replace one with the other. And you're trying to get the left-hand side to equal the right-hand side. Remember, if it gets messy as you go, eventually things should start clearing up and canceling. If it's not clearing up and canceling, then you're probably doing something wrong.